Hello, welcome back to Algebra 2. We are in Chapter 6, Section 3. We're on page 2. This is example 1, where we have to add and subtract a couple functions. Not very exciting, really, because while it makes it look like you're adding functions, and that might sound like a big deal, in the end, all you're really doing is adding some algebra stuff, and you quickly realize they're like terms because both terms have x to the 1/2. And so really, even if you want to make this look long, you're stuck writing like 3 minus 5 times x to the 1/2. And that really makes simply -2 times x to the 1/2. And that's your answer. Boom. I mean, if you want to look sly and slick, you can write -2 and then square root x, because x to the 1/2 is a square root. But that's just like reaching for style points. There's no difference between the rational exponent and the radical or square root version. For the part B, where we're subtracting, it's really the same thing. You have two terms that are like terms because they both have x to the 1/2. So again, even if you're trying to make it look long, you're stuck writing silly things like 3 minus -5 with x to the 1/2 factored out. That's just 8. So it's 8x to the 1/2. And you could rewrite that as 8 square root x. They're both equivalently awesome. And then finally, there's this discussion about domains. It says the functions f and g each have the same domain, and if you ignored me about the square root before, maybe go back and look at it now, because this is x to the 1/2 for both of them. The real issue is that x has to be greater than or equal to 0, right? Because if x was a negative number, then you have a square root of a negative number, and there aren't real answers to that. We have that silly I business to work with those, but there aren't any real number answers to that. And so to follow through, so the domains of f plus g and f minus g also consist of x greater than or equal to 0. Remember, the domain of your addition function or your subtraction function is kind of the same as the domains that work with the functions to begin with. So that's pretty much it for example 1. You look down at example 2, and here we're multiplying a couple functions together and then going to divide them. So for part A, to make it look exciting, it says, oh, look, it's f of x times g of x, but it's just times. And I'd like to remind you that, that means we're doing 7x to the 1 times x to the 1/6. That's, 7, and then the exponents add, because that's what happens when we when we multiply variables together. The exponents add. So it's 7x to the 7/6. If you wanted to go off the rails and try to be really cutesy, you could do something like 7, and this could be the 6th root of x to the 7th power, but normal, emotionally healthy people don't do that unless they have to. For part B, you have to divide them. Well, okay, we multiplied them before. Dividing, you draw a fraction bar. 7x over x to the 1/6. Remind you that x and 7x is really mean 7x to the 1. So since we're dividing, the exponents subtract. So it's 1 minus 1/6. So it's 7x to the 5/6. And that's it. I guess, again, if you were trying to be a show-off, you could talk about how that's the 6th root of x to the 5th, but doesn't really matter. So that's right. This is right too if you want. I guess going back to the part before, that was right. But either way, you've simplified the exponent. That's what matters the most. All right, so now let's look at part C, this one's a little more interesting than in example 1, because it says the domain of f consists of, if you look at f is that 7x thing, and that's all numbers, so all real numbers. And by the way, that's kind of a lot to write for something we're going to write a lot in life. So someday somebody will teach you that that's the same as an R with a double back down the side, but not today. I didn't teach you that. Okay, and the domain of G consists of, now G is this thing where it's x to the 1/6. Excuse me. So since we're talking about sixth root, even root, x has to be greater than or equal to 0. So the domain of f times G consists of, and here we have this is where it's actually more interesting, because the domains are not the same for each of the functions. So you take numbers that are in both of them at the same time. So x has to be greater than or equal to 0. And that's wonderful for multiplying. But there's something else going on with dividing. And that is that, if you stick 0 into G, you get 0. So that won't work for the dividing problem, because you are not allowed to divide by 0. So instead of saying x is greater than or equal to 0, we're going to say x is greater than 0 for f divided by G. And the distinction there between the two answers for the domains is that you're cutting 0 off. You're not including 0, because that makes the denominator 0, and that just ruins all the fun when you've got a fraction. Anyway, that's it for page 2, and thank you for watching.